My name is Chen. I'm the CTO at Rarity Bioscience. Today, I'm presenting Rarity for the CYTO Technology Showcase 2025. So Rarity offers a unique solution to the flow cytometry platform to enable the flow cytometry to detect molecular markers, for example, mutations, insertions, and deletions at an unbeatable precision manner, down to 1 in 100,000, much deeper sensitivity than current molecular assay competitors, for example, ddPCR and NGS can provide. And also the assay is very cost effective and utilizing existing equipment in the lab. The superRCA assay works as follows. It utilizes a manual 8-channel pipette together with a thermocycler for the incubation. The assay takes purified genomic DNA or cell-free DNA as input with a preliminary initial 10-cycle PCR sequence of interest were amplified into double-stranded PCR products. Then one strand of that PCR products were converted into circular template. That template will be replicated through a rolling circle replication mechanism to create a long linear concatenator composed with several hundred copies of sequences complementary to the circular template. And then a pair of genotyping probes, which we call topological probes, will contact with linear concatenator and do the genotyping. Imagine you have several hundred probes genotyping on the same template, then they are following the majority voting concept. Any false ligation of the genotyping process will be neglected by the majority voting mechanism, and then these circular probes will replicate again to enhance the signal. So in the end, you will have a DNA particle with millions of copies of sequences available for the binding of the detection oligos. Then you can apply different fluorescent oligos to these DNA particles to make them fluorescent readable on the flow cytometer. So this is how the particles looks like in reality under the scanning electron microscopy. You have this major sweeping motion, which was determined by the first rolling products, and then the subunits. Here you see like popcorn are the second generation RCA products. So by flowing the fluorescent labeled two-party products into the flow, then you will get to two populations. Here we typically assign the FITC channel to the wild type population and the APC channel to the mutant population. Then here you can see there are two populations in this data. And also here is another example of the flow raw data. In the left is EGFR wild type sample. Then you see there is no mutant events in the red gate, while in the right is a controlled 1% EGFR sample. Then you see approximately 1% of mutant populations in the red gate. The most important impact of our superRCA technology is it converts a pure proteomic platform into a high-performance genetic analyzer. So the conventional ddPCR can detect single SNPs at 1 in 1,000 level. Typical NGS analysis can detect a mutation at like 0.5%, while with UMI it might reach 1 in 100,000, but still at a great cost coming from the reads. With our superRCA assay, we can easily achieve 1 in 100,000 sensitivity with the single SNPs using conventional flow as a readout. We have filed several patent applications. Now they are under different stages of the patent application, and we are continuously filing for new patents. We have concluded that we have freedom to operate by an FTO analysis done by our collaborating lawyers. 3 years ago, together with other co-founders, we incorporated Rarity Bioscience in Sweden to commercialize this superRCA technology and make it available to the flow cytometry community. Currently, we have a team of 14 people with different backgrounds, including R&D, product development, quality and regulation, business development, and administration. Now we are looking for an efficient and effective channel to introduce our technology and the product to the flow users, to make them feel the product and try the product.